All right, let's go ahead and get into section 5.2 today. We're going to apply properties of similar triangles. So similar to yesterday, all right, we're dealing with similar triangles, so we want to stay with a pattern to set up our proportions and then cross multiply and solve. All right, so let's go ahead and get going. The first thing is our triangle proportionality theorem. All right, so here's the deal. We have a triangle that gets split by parallel lines. All right, so what happens is we want to stay with a pattern. The whole thing is to be consistent with your pattern. So for example, AE over EB, if I stay with that pattern on the other side, I want to go AF over FC. All right, so we're going to split it up. There's technically multiple ways that we can solve this. All right, but we want to be able to go through and stay with a consistent pattern to set up our proportions, our fractions, and then cross multiply and solve. So for example, there's multiple ways we can set this up. However, if I stay with a pattern and I stay with 2 from my first line, all right, 2 from my first line. So I could highlight it in a pattern that I want to go. So let's say I started with the 10 and then went over the 8. I can write that as a fraction, 10 on top, 8 on bottom. Now, if I stay with that same pattern on the other side, all right, so if I go pattern, I want to stay the same piece first, so 14 first, over my next part of my picture would be find CY. Well, we don't know what CY is, so I'm going to put the letter X there to solve for it. All right, now we can go ahead and cross multiply and solve this. All right, so remember when we cross multiply, I'm going to go ahead and I'm going to take 10 times X, which will give me 10X, equals 8 times 14. 8 times 14 will give us 112. Now, if I clean this up and divide by 10, I get X to equal 11.2. Now again, we say there's lots of ways to set this up because you could have done a different pattern. Let's say I went top 8 to the bottom X, and then I went top 10 to the bottom 14. You'll notice when we cross multiply, we're cross multiplying the same things. 10X equals 8 times 14 is 112, and if we solve that, we get the same answer, 11.2. So again, this whole thing is staying with a pattern and staying consistent. All right, let's go ahead and look at another. It says that CA is 10, so the whole thing is 10. It tells us that CE is 2, so I'm going to put a 2 on CE. It says DA is 6. It wants us to find DB, so let's put an X on BD. Now, you'll notice this left side told us the whole thing was 10. Well, if I know this piece is 2, then 10 minus 2 tells me this part of the line was 8. All right, now, the whole thing we want to do here is we want to stay with a pattern. So, as long as I stay with a pattern when I set up my two fractions, then I'll be fine when I go to solve. So let's say I work this side first. I started 8 first, and then I went over the 2. If I did that, then I want to go back to my other side and stay with the same pattern. 6 over the X. Now I'll go ahead and I'll cross multiply and I'll solve this. 8 times X will give us 8X. 2 times 6 will give us 12. If I go and I divide both sides by 8, I get X to equal 1.5. Now again, there's lots of ways you could have set it up as long as you stayed with a pattern. Sometimes kids might go 8 over 6 equals 2 over X. Again, you'll notice once I cross multiply, because I stayed with the consistent pattern, This is the same exact as what we did there. So make sure you just stay with the pattern to set up your two fractions and then cross multiply and solve. All right, that gets us to our second property for today, the two transversal proportionality. All right, so now we have parallel lines that are cut by transversal. So what we're going to do is we're going to stay with the consistent pattern to match things up. So for example, they tell us AB first. Then they say that should go over DE. So we have our pattern. Next, in our fractions, they tell us BC. So if I go to highlight the pattern, it would have been E to F, so my answer for this is EF. All right, let's go ahead and erase our picture, and let's see if we can match up the pattern for the next one. They tell us AB to start over AC, the whole thing. So our pattern on the next one will be the small part first, DE, over the whole entire thing. All right, so let's go ahead and fill it in with the two letters for the whole entire thing, which would have been DF. So again, we're trying to match patterns so that we stay in a consistent form. Let's go to the third one. The third one says AC first, and then it tells us C to B second. So notice if I stay with that pattern, I went AC first, so I want to go DF, the whole entire thing, in order to match our pattern. All right, let's try one more. AC, the whole thing, over DF, the whole thing. Then they tell us B to C. So we want to use the same pattern. We're going to call it E to F. All right, so when we go to solve these, we want to stay with the pattern to set up our two fractions and then go to solve. So for example, this picture says to solve for x and for y. Now, the problem is that you'll notice there's multiple x's in the picture. So what I'm going to do is I'm going to stay with the pattern to set up two fractions. So I'm first going to take the 8, and I know that that matches with the 6. Equals, if I go to the next piece of the picture, I notice an x plus 5, and that could go with my x. I'm going to cross multiply and solve this, and watch how we do the cross multiplication with multiple things in it. 8 times x will give us 8x. What's technically happening here is I need to take that 6 times the x plus 5. Well, if we clean this up and start to solve, I get 8x equals, let's distribute, 6x plus 30. Solve it, subtract 6x. I'm left with 2x equals 30. Divide by 2, and I get x to equal 15 for the first part. Now, I'm going to take that 15 and I'm going to go back to my picture and I'm going to plug it in. So I know that this should have been a 15. This should have been a 15. If I do 15 plus 5, I get 20 for this piece. Now I'm going to stay with a pattern to set up my next fraction. So remember, 20 would go with the 15. Equals, stay with the pattern, 2y plus 6 over the other 15. Now again, as long as you stay with the pattern and stay consistent, it should always match up. All right, remember we're going to cross multiply. So 15 times 2y plus 6 should be equal to 20 times 15. Now, 20 times 15 will give us 300. So to find y, we need to distribute this and solve it. If I distribute, I get 30y plus 15 times 6 when you distribute it will get you 90. And that should be equal to 300. Subtract 90 from both sides. I'm left with 30y equals 210. And now if you take 210 and divide it by 30, we should get y to equal 7. So again, there's multiple ways that we can set these up. We need to stay with a pattern. If you stay with the pattern when you set up both fractions and stay consistent, then we simply cross multiply and solve. All right, so let's go ahead and look at the third and the final thing for today. We're going to look at the angle bisector theorem. So again, it's going to split it and make us do a pattern. There's multiple ways we can do them. All right, in this picture, CD is the angle bisector. Notice the curls in our picture split those into two equal angles. So angle ACD has to be equal to angle BCD. Now, the whole thing with this will be to stay with a pattern. So, for example, I could do side CA, the left side of the triangle, over AD, the bottom part of the triangle. And if I stay with the pattern for the other one, I would do CB over BD. All right, so again, we can go left to bottom, right to bottom. I could go left to right, left to right. As long as we stay with the pattern in this picture, it will always get us to the correct answer. So let's look at an example with an angle bisector. When I do this, as long as I stay with the pattern, there's multiple ways I could set it up. So let's say I wanted to start with this first triangle here and take 40 over the other side of that triangle is x plus 2. If I set that equal to the pattern for my second one, I would go 32 over x minus 5. Now again, there's multiple ways that you could set this up. Some people might have gone left to right. So some people might have said, well, what if I went 40 over 32 equals x plus 2 from that original triangle to my second triangle? That would be the same as what we're doing up above. So again, if you stay with the pattern, your equation is technically going to get to the same result at the end. All right, I'm going to go ahead and solve this. So remember, when we cross multiply, I need to take 40 times the x minus 5. So I need to multiply it times both. Equals, if I cross multiply the other two, I have 32 times an x plus 2. All right, I'm going to distribute this. 40x minus 200 equals 32x plus 64. Now let's go ahead and solve. Subtract 32x from both sides. I'm left with 8x minus 200 equals 64. Add 200 to both sides. I'm left with 8x equals 264. Last step then, divide both sides by 8, and I get x to equal 33. Now, if it wants us to find the other two sides, we just need to go back and plug it into our picture. If I plug 33 in here, 33 minus 5 tells me that SR is 28. if I take my 33 and I plug it in right here, 33 plus 2 tells me that PS was 35. All right, so again, stay with a pattern to set up your two fractions. Once you do that, you can cross multiply and solve. All right, let's go ahead and go through some last examples here. And we'll clean it up, make sure you're good, and then we'll get into some practice after that. The first question says find LA, so let's put an X on LA. Now, again, there's lots of ways we can do this. We want to stay with the pattern. So I could work the top figure first, and then the bottom side of this figure, I could go top to bottom, whichever way you want to set it up. So for example, if I started with this line, and I went X over 12, I want to keep the same pattern for this line, so I would go 9 over 4. Again, there's multiple ways you can set this up. Cross multiply, I get 4x equals, cross multiply, 12 times 9, and you get 108. Go back and divide both sides by 4, and it tells us that x was 27, so LA was 27. Okay, let's go to the next one. I've got to stay with a pattern, so I'm going to solve for the x first. It doesn't matter which one in this case. So I'm going to go 2 over 3. That pattern for the next one would have to go x over 5. All right, let's cross multiply and solve it. 3 times x is 3x. 2 times 5 is 10. Divide by 3, and x equals 3.3. Now I'm going to go back to my picture, and I'm going to try to come up with a pattern to find y. I'm going to go 3 and then y. If I do the same pattern on my next one, I'm going to go 5 and then 8. I'm going to cross multiply that. 5 times y is 5y. 3 times 8 is 24. I'm going to finish it up by dividing both sides by 5. And I get y to equal 4.8. All right, again, pattern, 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 and you should be all good. Our last one is an angle bisector. Again, I could go 8 over 6, x plus 2 over x minus 1, so I could work left to right if I want. I could work right to left if I want. Or I could work triangle over bottom of the triangle equals triangle pattern over the bottom of my triangle. And now I'm set to go ahead and solve this equation. So again, your equations will be cross-multiplying the same thing as long as you stay with the pattern. I'm going to go ahead and cross-multiply these two. So 8 times x minus 1 should be equal to 6 times x plus 2. I'm going to distribute on both sides and rewrite it. So 8x minus 8 should be equal to 6x plus 12. All right, let's solve it. Let's subtract 6x over. I'm left with 2x minus 8 is equal to 12. Let's add our 8 over. 2x is equal to 20. And last, I'm going to go back and divide by 2, and I get x to equal 10. So what you'll notice with all three of these theorems or properties is that as long as you stay with a consistent pattern setting up your two fractions, you'll get to the same answer either way. Just stay consistent in your pattern. Whatever you do for your first fraction, we got to stay the same order for our second fraction. All right, we're going to go ahead and get into some practice now and do some examples